and gentlemen, welcome back. Sit on down and just hunker in. We got a good lesson today. We got a new concept, probably the last new concept in all of AP Stats. Give it up. All right. So last new concept. Last chapter we talked about confidence intervals, which is under this arcing title of inference, right? Remember, inference is taking a sample of something, right? Not necessarily accurate, but taking a sample as best as we can and applying it to the whole population. That's an inference, okay? So when I infer about something, what are you inferring about? I'm taking just stuff from around me, some samples, and applying it, saying this is how it really is. That's what inference is. All right, we talked about confidence intervals, which was either x bar or p hat. Remember, x bar plus or minus my critical value times my, and we kind of switched it over in the end. It's really kind of actually our standard error, but you could call it our standard deviation too. The whole point of a confidence interval, and I'll probably ask this to 50% of my class and they don't, what's the point of a confidence interval? You are estimating where the true population average is, right? Our sample is just a sample, not necessarily accurate. Confidence interval gives me an interval saying, man, I am 99% sure the actual amount is somewhere between here and here, right? Okay? Alright, so like I am 90% sure I'm going to get between a 95 and a 98% on this test, right? Okay. There's still 1% of error. Next, our next topic, what we're going to be, is still a branch of inference, and it is called a significance test. Otherwise known as, we abbreviate a lot just a sig test. Okay, not a sig, not testing sigs. Okay, it's not testing sigs. Alright, it's a significance test. Gotta get that straight. Okay, alright. Down around the corner at the Smoker's World. Okay, alright, so what is it all about? Well, I don't know if you guys have ever heard of hypotheses or not. But I love this chapter because basically what you're doing is you're saying somebody makes a claim about something and you say, I don't believe you. Okay? Just an iBlock today. A bunch of people playing BS. It was a great game. People just calling people out. I don't believe you. Right? Okay? So basically, people make claims all the time. Right? And we need to go out and investigate to see if it's actually true, right? That's what we're going to be doing here, all right? We're going to say, I'm going to reject your claim, or, the alternative, which we'll talk about, all right? I'm super excited about it. I hope you are. There should be probably about 2 parts to 9.1, and 9.1 is basically the nuts and bolts of this whole thing. We're going to get into z-scores again, which I think you know how to do in 9.2, 9.3. So really 9.1 is the whole gist. It's the whole idea of what a significance test is. So without further delay, let's get going. All right, a null hypothesis is what we have to assume to be true right away. We call this our HO. All right? Which, I don't know if anybody knows the programming or anything like that, but we always represent null objects with like a 0, meaning it's not, null isn't 0, right? Null means it's an empty set. It just doesn't have anything in it. It'd be like if you have a cell, right? You don't have any number in there. That's null, okay? And I don't have 0 in there. It's just nothing. I mean, there's not even a number in there. That's what null means. So the null hypothesis is written as HO, and that is what we have to assume to be true. So your null hypothesis is always going to have like HO, and we're going to say equals something. All right. So, just throwing this off the top of my head, let's just say, somebody says, I got a 4.0, right? I got a 4.0. So, our null hypothesis is basically, and I should have given myself a little bit more room, it's going to be HO should equal what we're going to, we're going to assume you got a 4.0, but we're going to go out and check some stuff out, right? We're going to maybe say the mean is going to be 4.0, right? I'm going to take you at your word because you are innocent until proven guilty. And this is a lot like law, this chapter, all right? We're going to prove them innocent, or they're innocent until proven guilty. Okay? The alternate is labeled HA. Okay? This is what I think you're lying, basically, right? Is what we're trying to prove. This would be the alternate. So we've got the HO and the HA. So it's hoes and ha's. Ho-ha, ho-ha. Okay? This one does not have a equal to. Basically, I have to decide, okay, there's a couple options here. Do I think they have higher than a 4.0? Is that what I'm questioning? Do I think they have a higher than a 4.0? Or do I think they have a lower than a 4.0? Right? So, in my case, my alternate hypothesis might be, I think you're lying to me. I think your average GPA is actually lower than 4.0. Okay? And there we go, right? That's would be your alternate. I could do greater than or less than. Okay? So here are our options, okay? Our one-sided would be, our alternate will be either less than, I don't know why this blue line is here, so it would be less than, or maybe I might think another one-sided would be, hey, you know what? I think he's lying to me. I think he's got a greater than a 4.0, which, you know, obviously, you know that can't happen. But sometimes we want to think, you know what? I think they're skirting it, right? You know, when it says, oh man, I waited around for like, no, that's the opposite. You know, I don't know. I was thinking, you know, I waited around for 15 minutes when really they actually only waited around for like 2. That would be under again that we think they're lying about. But anyways, those are my two sides, right? This is why we call it two-sided. Okay, the under would be this guy, right? We think is going to be under. The over would be this guy right here. So that's why it's called a one-sided, because it's either they're under or they're over. Okay? And then a two-sided test, all right, would be, you know what? Man, you know what? I just think they're lying to me. I don't know if they're over or under. I just think they're lying to me, you know? And so that, a two-sided test, I would write the mean is, a two-sided test would be, you know what? They could be either low or they could be high. I just think they're lying. So I can't put equals because that's the claim, right? That's the hypothesis, would be that it exactly equals. So basically it's just saying, I don't care if it's below or above, I just think they're lying, so I think that they're not equal to. It's not equal to 4.0, right? And in my GPA case, I could, you know, they don't have a 4.0. That would be, could be higher, could be lower, they're just lying to me. Okay? All right. That is hypothesis in a nutshell. All right? Couple things you need to make sure you watch out for, because they try and trick you on a lot of things. And I know we're already 10 minutes in. You will not have a hypothesis with an X bar. You will not have a hypothesis with an X bar, okay? Because we are trying to prove the overall, the population, you know, his overall score is a 4.0, right? We don't want to know if our sample is a 4.0, right? So we will never have X bar, we'll never have P hat, okay? Could we have in a different situation, we could have P is equal to 6%, right? I don't know. I'm just coming up with something. I don't even have a story for this. And our alternate would be P is greater than 6%. You know, I could do this, right? But notice, once again, I'm not going to have a P hat. That's not what I'm estimating. I am estimating the whole population is something. Okay, so you'll never have that. Also, your hypothesis, your null hypothesis will always be equals. It's not going to have a greater than or less than symbol. It's always equal to. All right. Okay, so let's see a couple situations here. Does job satisfaction of assembly line workers differ when their work is machine-paced rather than self-paced? One study chose 18 subjects at random from a company with over 200 workers who assembled electronic devices. Half of the workers were assigned at random to each of the two groups. All right, so that means 9 of each. Okay. Both groups did similar assembly work, but one group was allowed to pace themselves, while the other group used an assembly line that moved at a fixed pace. After 2 weeks, all the workers took a test of job satisfaction. Then they switched work setups and took the test again after 2 more weeks. The response variable is the difference in the satisfaction scores, self-paced minus machine-paced. Ooh, this is a tough first question. All right, so the null hypothesis, sometimes I like to state the null first, all right? And I like to come down here first, all right? So basically what I'm saying is it's the difference between these two. All right, now I've got to pause for just 1 second. I'll be right back. All right, sorry, I had a computer issue. So my appropriate hypothesis would be HO. All right. And what are we talking about? Are we talking about means, proportions? What are we after here? It says it's about time and how fast people did their score, right? But it's the difference of those. So it's a mean problem, and I'm saying the mean difference. And if you want to write the mean diff down here as a subtitle, go for it. The mean diff. Okay, so between the people who were self-paced minus the machines paced, I'm saying will be equal. What should we assume those two paces are, right? What are they? Should they be separated by like 1 minute, 2 minutes? Well, I think what we should assume right away is that there is no difference between them. So what should the difference be? 0. Does that make sense? This is, like I said, I'm not a fan of this first question here, but you'll see tons more examples, all right? My alternate, all right, what am I actually trying to see here? What does the question actually want me to test? I'm saying that the mean diff is what? Greater than, less than, what do they want here? It says, half the workers were assigned. After 2 weeks, all workers. Does job satisfaction of assembly line worker differ when their work is machine-paced rather than self-paced? All it does is say, does it differ? It doesn't say, is one better than the other? Nothing like that. So I am just wondering if it's different. So I'm going to say, I want to know if it is not 0. Okay? So that basically means I'm assuming there's no difference. And then that it's, you know, I'm going to see if there is a difference. What is the parameter, okay? Parameter basically wants us to do is explain what is actually mean in this case, all right? And let me type this out quick. I'm going to stop it. I'll type out what I would put as an answer here for parameter. Once again, one thing I focused on here is you've got to put context. So when you do write a hypothesis and you say the mu is equal to 0 or the mu is not equal to 0, AP really wants to know what does mu actually stand for. And so you would say mu is the parameter, or the parameter is the mean difference in satisfaction scores, self-paced. So it's adding that context. Okay, I don't know if I can get this done in 15 minutes. This is a lot of talking here today. Hopefully we'll go through one more lesson and we'll get it. Okay?